Hey everyone, thank you for joining. I hope you had a great week since last Thursday. So it's been quite a packed day on my side, so we are going to take it slowly today. But we are going to talk about monitoring and NiFi. It's going to be fun. Before we do that, just a few information about well, some of the stuff that happened during the last week. Is it better? Do you hear me? Yes, okay, thanks. Sorry about that. Sorry about that. Okay, that's weird. I didn't change anything about my mic. Okay. Okay. Anyway, let's let me take back what everything I said. So I was saying that I had a pretty intense day on my side today with a lot of customer meetings. So I'm going to take it slowly. Before I go into NiFi monitoring, I just wanted to share with you that everything I'm doing on Twitch will be uploaded on my YouTube channel, and I'm going to share the link, but if you want to replay what happened last week, you can go to this YouTube channel. So right now this is a very awful name. I will be able to give a custom name to the YouTube channel so that the link is easier to remember once I reach, I don't know, a given number of subscribers. So anyway, here's the link. It's also on my Twitch channel. Everything we are doing, every session we are doing, I will be uploading the recording on YouTube because if I recall correctly, I'm not used to Twitch yet, but if I recall correctly, at the beginning, since I'm really starting with Twitch, all of the recordings are just kept for 2 weeks on Twitch, and I want something more permanent, so I will be uploading all of the recordings on YouTube as well. It can be useful, hopefully. So that's something I wanted to discuss about. Something else is the monitoring stuff I'm going to talk about today is actually following a webinar I did for Cloudera end of last year, I think, if I recall correctly. And if you want to watch the replay of this webinar, you can go there. Demystify Apache NiFi monitoring capabilities. So I will be also sharing the link with you without all of this stuff here. So this is just in case you want to watch the replay, because what I'm going to do today during this live Twitch session is to show you how what steps I did to, let's say, set up everything around the monitoring that I was showing during this demo. During the demo, I had already everything set up, and I was just showing the dashboards, things to look at, what you can do with the reporting task, and so on. Here, it's really about, well, what are the exact steps to get everything set up. Because this is something that some people asked me after the webinar, and I said that I would be sharing all of the information into a blog post, and I just never found the time to do it. Writing a blog post is super time consuming, and I didn't find the time to do it. That's on me. But anyway, now I'm on Twitch, and I'm going to talk about this today. Also, before we start talking about NiFi monitoring, something else I wanted to share with you is a quick update about what happened during the last 7 days in the Apache NiFi community. So as I said last week, there is a lot of things going on right now, very exciting stuff coming in the upcoming release. So the next release of NiFi will be NiFi 1.15. I think this is going to be released maybe this month or next month. We need to start a discussion in the community, have a thread, make the vote, and so on. So this is probably something happening in the near future. But just so you know, I wanted to discuss with you a few things that have been managed during the last 7 days. So this is something I want to do at every live stream I will be doing on Twitch. Just go through what happened during the last week. So last week we were the end of October, so let's go back a bit and let's have a look. So something we talked about during the session last week was this new stuff, parameter context inheritance, that I demoed last week during the live session. If you want to have a look, go to the YouTube channel, look at the video. It should be near the end of the session. Then what else? A few things around dependency versions. Not much I want to talk about. There is, however, something here that has been merged last week or earlier this week, which is a very big thing that I will be talking about in the next session. But just so you know, this is something that has been merged. This is a big one. Basically, there is this concept of NiFi stateless in NiFi. This is a way of running a very specific set of NiFi flows in a very specific fashion, like considering a flow like a single transaction, kind of. And using NiFi stateless so far has always been, let's say, kind of tricky if you are not used to NiFi. It was kind of a very manual process and so on. So with this pull request that has been merged, we have a new processor which is execute stateless, which will give you the ability to execute a flow using the stateless capabilities directly within the NiFi UI. So this is a big one because using NiFi stateless in NiFi provides things like flow file ordering, exactly once, semantics, things like that. So it's a big deal. It's a big one, and this is something that Mark has been working on for a while, and he's working on a blog post and video about this. So so I will be able to share more information about this very soon, and you will see some information about this on Twitter or LinkedIn or on blog posts in the very near future. So that's a big one. Something else is new processors for interacting with Elasticsearch. That's also greatly improving the capabilities of NiFi when it comes to interact with Elasticsearch. So yeah, definitely this one brings two new processors, and if you are using NiFi to interact with Elasticsearch, once NiFi 1.15 is out, you probably want to check out these new processors. And there is also another pull request being reviewed right now, which is going to bring quite a few nice improvements around the Elasticsearch processor. So stay tuned on this. And I think that's really what I wanted to mention for what happened during the last few days. These are really the big two recent additions in NiFi. So yeah, so I will go into more details about this in the future. And talking about NiFi stateless will be actually the main topic of my next webinar for Cloudera, which is planned for the 17th of November, so in about a month. So as soon as I have the landing page to register to the webinar, I will be sharing it on Twitch as well, on Twitter and LinkedIn. But yeah, I will be focusing on this new stateless stuff. Okay, great. Let's go back to monitoring. Okay, so here you should be used to it now. This is really the starting point when I'm using NiFi in public cloud. I'm using the Cloudera data platform. In this case, I deployed that environment on AWS. I have 3 data hub clusters, one for NiFi, one for Kafka, one for Flink. I will be only using NiFi today. Maybe I will be interacting a bit with Kafka so that we can have real metrics going into the dashboards and really see some cool stuff happening. But really, today the goal is we really want to go through the steps I followed to set up all of the monitoring around what I was showing during the webinar I mentioned. I just want to check something because last time some of you gave me some very good feedback about the quality of the stream, so I increased the quality of the stream, so hopefully you should be able to read everything on my screen. If that's not the case, if I need to zoom in, please let me know. But in theory, it should be much better than last week, I hope. And also, last week, someone told me that what I was showing with my mouth was not exactly the same on the screen, but it sounds like it's working as expected today. If there is something wrong with the stream and like you don't really understand what I'm showing or something is not right, please let me know. Because again, I'm still new with all of this, so I'm probably doing something wrong somewhere. Okay, NiFi cluster, let's go into it and go to the NiFi UI. That's something I've been using quite a bit today, so I'm going to do some cleaning because I've been using a lot of stuff that we don't want, and let's start from something clean. Okay, I have some data, empty all queues. Okay, and let's clean everything. Sorry about that. Just before this live session, I was in a customer call and I was showing some stuff. So I have a lot of things still around. Okay, I have something probably in there. And just stop this. Okay. Okay, we should be almost good now. Oh, sorry. Here. And okay, we have something clean. Okay, the first thing I want to talk about is really what we have in the UI out of the box, and then I will be talking about the integration with Prometheus and how to set this up and have Grafana dashboards connected to it, and how we can build nice dashboards showing what's going on in NiFi. Something I want to start with is really all of the things you have in NiFi out of the box when it comes to monitoring. The first step, and whenever you want to go in NiFi and look at what's going on, if there is something you want to improve or detect a bottleneck somewhere, things like that, the first step is usually to go into the summary table. So if you go in the summary view, you can see a lot of things about what's happening in your NiFi cluster. You have a lot of things about what's going on with the processors. Let me actually do some stuff here, and an update attribute just to have things running but not to do anything useful. Okay, here. Okay, and I'm going to auto terminate here. Okay, and if we start, okay, so now I have some data being generated. I'm going to have back pressure. That's all right. So if I go in the summary view, you have some information about the processors. This is useful because you can see here how many threads are being used. So that can be a metric that is useful to see very quickly if there is a processor using a lot of threads. You can have some interesting statistics. You can very quickly go to where in the canvas the processors are located. So it's very useful to quickly go to where there is something happening in a flow. If you look at the connections, this is also super useful because you can easily go where well, you have a lot of data in a connection. So you can sort the list by thresholds, by queue size. If you sort by queue size descending, well, you will have the connections where you have a lot of data, and that's probably something you want to look at. So this view is super useful. You can also switch from a single node if you want to look at a specific node, because sometimes you can have one single node doing something weird and you will want to look at the statistic for one given node. But something you can do as well is to click here, and this will get you to the status history of this component. So in this case, I'm having the status history of this connection, and I can look at, for example, flow file in, and I can see here that well, I have a lot of data. And something that is super useful, let me go back to normal size here. Something that is useful here is that you have an aggregated view for your NiFi cluster, but then you have the details for each one of your NiFi nodes. So if you want to look at a specific node, you can unselect the other ones and you will get the information about only the specific node you want. You can also select a specific period of times here, and it's useful. So that's something useful, the combination of the summary table and status history information for the components. That's where you can have quite a lot of information and drill down to specific nodes in case, I don't know, the nodes are not performing at the same pace, for example. So that's useful. That's really the first thing when you want to have like, okay, you have been alerted that something wrong is going on. You access to the NiFi UI because you are the admin or the, I don't know, the person in charge of operating the NiFi cluster, going into the summary table and then look at what's going on and then go to specific status history. Information can be really useful. So that's something to keep in mind. The next one is obviously the cluster view. Cluster view is always useful. You can have information about well, what's going on with each one of your nodes in terms of really the NiFi service, not what's going on in the flows, but really the NiFi service. So that's useful to see if some nodes are overloaded. For example, if I go in the system view, I can see that I have 8 cores per node and the load average is currently around 3. So, well, my NiFi cluster is not doing nothing. It's not much, but it's active. It's processing some data. In this case, that's because I'm trying to generate a lot of data. As you can see, I'm generating millions of events and just dropping the events. But doing this is still doing a lot of I/O access. So it's processing quite a bit of data, even if it's not doing anything from a data processing perspective. So that's useful. Looking at the GVM is always useful. So you can also look at the storage for each one of your repository, flow file, content, provenance. These are things to monitor. Obviously, like any system, you don't want a full disk. And then versions is useful. In this case, you can check the Java version. In this case, I'm using Java 8. You could use Java 11. We are probably going to start looking at Java 17 now this is out. But right now, just using the old good Java 8. So this cluster view is super useful as well. Okay, checking if there are questions. No questions. Cool. So the next thing that you want to check, and that's fairly recent in NiFi, this is something we added like, I don't know, 6 months ago, something like that, is this new node status history information, and that's super useful. Basically, everything I've been showing so far is monitoring information about what's going on now when you are looking at the UI. This view is giving you a status history capability, like the history of all of your data, but for the system metrics over time. So that's useful. You can see, for example, for the last 24 hours, the use of my heap, but you have many metrics. So looking at something like the heap is super useful in case you want to check for, I don't know, a memory leak in your flow, something like that. Open file handles is also something very good to look at in case there is a leak as well. So in this case, this is really stable, no issue with that. Number of total threads. This is from a JVM point of view. We can see that this is not balanced across the nodes, but that's because my NiFi 2 node is the primary node and my NiFi 1 node is the coordinator node, which means the NiFi 1 node receives the heartbeats from the other nodes. So we have more threads here. If we look at number of time-driven threads, so the threads actually used by NiFi to do the processing in my flow, this is what we want to look at. This is something super useful because something that is very frequently asked is how should I set the number of threads that processors can be used in NiFi. So if you go in controller settings here, you have here a thread pool size, which by default is equal to 10. And this number is the number you have per node, meaning that each node in your NiFi cluster is going to have a thread pool of 10 threads that can be used by all of your components in your flow definitions to do the data processing. It may sound like a small number, but this is actually a very fine default value. And you can already process a ton of data with just the default. So I know many people are going straight to this page and setting crazy numbers for this thread pool. This is not something you should do. What we usually recommend is you can increase this default value to 3 or 4 times the number of cores you have on your node. So in this case, since I have 3 nodes, 8 cores each, I could, let's say, increase this to, let's say, 32. That's all right. So I could do this if I want, and it means that each one of my node can use up to 32 threads. So if you look at the NiFi UI, right now I see that my processor here is using 2 threads, this one is using 2 threads as well. If I refresh, I should see different numbers, 3 here, 1 here. Don't forget, this is an aggregated view across the cluster. So the numbers you see here represent the number of threads used for this processor across all of the nodes. Same here, the number you see here is the number of threads currently being used across all of the nodes. But now the question is, how do I know when I need to change the size of my thread pool? Well, you shouldn't change it until you actually reach the limit. So if you remember, right now I just changed the value to 32. So if I multiply 32 by the number of nodes I have in my cluster, we get to 96. So as long as I don't see 96 here, it means I'm good with whatever settings I have and I don't need to increase it. If I have some performance issues somewhere in my flow, I should probably look at something different, and it's probably going to be the IOs on the disks instead of the CPU. But something that is always very good to look at is going back to the node status history. and then go to the number of time-driven threads. And here I can see per node and across my cluster how many threads are used, and I can check if I'm reaching my limit. And we are far from the limit in this case because my limit will be 96. But assuming I'm reaching the limit, how to check if I can increase even more this number? Well, I could look at the load average on my cluster. If the load average on my cluster is very high already, I probably don't want to increase even more the number of threads available to my processors. If I have a lot of threads being used but not doing much, well, in that case, I may consider increasing the number. What I mean by threads being used but not doing much, it can be a processor like Listen HTTP. So Listen HTTP, or all the listener processors, is going to use a thread, but this thread is basically not going to do much, because if you are not receiving data from clients sending data over HTTP, this thread is going to be used but not for doing much. Same if you are using processors like Consume Kafka processor. If you are checking very frequently if there is no new data to consume from Kafka, you are going to use a thread very frequently to check for new data to consume. But if your Kafka topics you are connected to do not have a large throughput in terms of data, well, these threads are not going to do much. So really, before increasing the number of threads, you should be very careful about what's the load average on your node already. So really consider the two together. Okay, so that's really what I can talk about when it comes to monitoring the system. Like you need to access the NiFi UI and check what's going on. That's one thing. Something also super useful, and very often people are not aware of this, is the diagnostic stuff. So let me go to my hardware here and SSH to a node. So I'm going to SSH to one of my NiFi node, and I need to switch tabs. So just a sec. Okay, so I can probably zoom a little bit here. I don't know if this is, you can see something, but hopefully you can. I don't know if it's really, I'm trying to find the right size. Hold on. Yeah, hopefully this is looking better now, and you can see what I'm typing on my screen. If you can't, let me know. Thanks. So yeah, so let's SSH here to one of my nodes. So I'm going to SSH to one of my nodes, switch root, and I can check where my NiFi process is running. Okay, let me, because I'm not used to have something so big on my side. Okay, so here, if I go there, I should see it. Okay. So basically what you want to do is to look at the nifi.sh file. Basically what we want to do here is to use this file. So let me remove this. And if we look at this, you have a few options here. Something that is super useful and that you need to be aware of is first the diagnostics. So diagnostics is super useful in case you want to have like a screenshot of what's happening in your NiFi node. So it's going to get all of the information about what's going on. And if you don't specify the destination of the file, by default it's going to go in the Bootstrap log file. If I recall correctly, it's in here, and NiFi Bootstrap log. So if I print this, well, you can see a lot of information. Let me actually provide the file, and myfile.txt. Okay, and if we look at that file, we have some information that is super useful about what's going on. So you have, it's really taking a snapshot about a lot of things happening in your NiFi cluster. So you have things like thread count, how the JVM is used, all of the NARs being available and loaded into the system. This is also something super useful. Some information about the flow and what's the state of the flow, how many flow files, things like that. You have some information about the clustering. You have some information about the garbage collection, things that could be useful to check if there is something wrong about garbage collection. So I'm going to go through all of this. That's a lot of data, and then we have a thread dump. Okay, I'm going to, okay. Then we have information about the repositories. So that's also useful, how the repositories are configured. In this case, you can see, I mean, this is what we recommend, to have dedicated disks for each repository, which implementation I'm using. So right ahead for flow file and provenance repositories. So we can check that this is looking good. I have the number of components deployed on my NiFi. There is a question. No, this is the NiFi SH open source. So if you just use open source NiFi to start NiFi, you will do nifi.sh start. In this case, for running NiFi, you can just do NiFi SH diagnostic. This is not something specific to Cloudera. Everything I'm talking about is available in the open source Apache NiFi project. Nothing Cloudera specific here. So yeah, so we have the component counts. We have some extract of the NiFi configuration, which is usually some of the, let's say, most critical properties in the NiFi configuration. So that's what we are extracting when we are making a diagnostics, because this is usually something we want to look at in case we are seeing something wrong. So this is also useful information. And then thread dump with all the threads that are used when you are running the diagnostics. So usually, if you are used to the Apache NiFi mailing lists in the community upstream in the open source project, usually if you are subscribed to the users mailing lists and someone in the community is reporting an issue with NiFi, well, usually one of the things we ask for is either the diagnostic or the thread dump. So in the diagnostic file, as you can see, you have the thread dump, but you can also use nifi.sh to only do the dump of the threads, which is also super useful when we want to debug something, like a processor being stuck. For some reasons, we don't know. You can't stop a processor, or a processor is always running and is not doing what is expected, things like that. Well, it's usually super useful in this case to do a thread dump. So you can do the same, nifi.sh dump, and send this into a specific file. Oh, sorry, just not typing right, but okay. And if I show the content in this case, it's really just a thread dump with all the threads being used in NiFi. So this is super useful if you have issues with NiFi, or you notice a memory leak, something like that, taking multiple thread dumps with like a 1 minute interval is usually something we ask people in the community to help debugging issues. So yeah, so that's something to be aware of. That's something useful. Okay, let me go back to the other screen. Next time I will prepare this better with multiple scenes so that I can switch from one to another easily. Okay, we are back to here. Okay, so now that's great. I just discussed about all the tools that someone in charge of operating the NiFi cluster may be aware of. Now there is a lot of things that NiFi provides that you can configure by yourself on your side to go one step further. Actually, before I go to this, there is something I wanted to mention that I just remembered. So this node status history is a new thing, fairly recent, but something that is really important is that just like all of the status history that you can see for a given component, all of this information is something that is kept in memory in NiFi, and we keep only the last 24 hours. And if NiFi is restarted, you don't have the history of all of this information. Meaning that if I restart NiFi now, and I wait for the UI to be available again, and I go back to this status history view, well, in that case, I won't see anything. I will have to wait, and the new data will be collected and so on, and I will get some information. Obviously, very frequently, when there is an issue, well, usually some people, the first thing they do is to restart NiFi. And by doing this, you are losing quite a lot of useful data, and that's kind of a shame because it's going to make things harder to understand what happened. So something we added is the ability to save this data, persist it. So if you go into the help and administration guide, you can see some of the parameters you want to set to keep all of this information. So status history repository is a new stuff. And you can see here that the NiFi component status repository implementation by default is the volatile one, which is basically in memory. If you want to switch to the implementation where this data is persisted across NiFi restarts, you want to configure this value to this embedded QuestDB status history repository. And then if you want, with the persistent repository, you have additional properties that you can set to define how many days you want to keep the data. You have the number of days to keep the data for the node status history, really this information. And then you have another property for how many days you want to keep the information for the components. Yeah, so like this information. So this is a new thing that is important to be aware of. Hi, thanks for joining. So yeah, so that's something to be aware of. This is fairly recent, and the default is still the in-memory implementation. We will probably change the default to the persisted repository in the future, but we didn't want to do it by default for users of NiFi because we want to make sure that we are not breaking things. So this is something to keep in mind. Yeah, okay. So now something I want to talk about is what you can configure, things you can add in NiFi to improve your monitoring. and the first thing you want to look at is to go into controller settings and go in the reporting tasks. That's really the first one. I'm going to stop my processor here because this is just creating a lot of pressure on the provenance repository for no reason. Let me go back here. So in the reporting tasks, you have quite a few information. Let me remove this one for now. By default, when you are using NiFi with Cloudera, you have 5 default reporting tasks configured for you out of the box. And what we are doing here is, well, the first one is Atlas reporting task, but this one, I won't be talking about this one today. This is for the data lineage, something we provide with Cloudera, and the integration between NiFi and Apache Atlas, which gives you a very powerful way of having the data lineage of your data when you are using many components for an end-to-end pipeline. This could be a dedicated session to discuss about lineage and Atlas and the provenance data with NiFi and so on. This will probably be a dedicated session. Then we have 3 reporting tasks configured for checking the disk usage for the 3 repositories: content repository, flow file repository, and provenance repository. To be honest, well, if you are not using Cloudera products, these are reporting tasks you should set. And if we look at the configuration, basically we are saying, well, if the file system that we are using for this data is going over 80%, please warn me. I want to be aware of this because this is probably the sign of something really wrong. So having these 3 reporting tasks is a must-have, according to me. But yeah, up to you. But full disk is never a good thing. So having the reporting task to check the disks is a good idea in my opinion. So what is going to happen in case we go over this threshold is that this reporting task is going to generate a built-in, just like you can see one here, which is in this case specific to the Atlas one, but that's an error we can ignore. Sorry. But basically it's going to generate a built-in. And the built-in is the way that NiFi has to surface errors happening at the framework level or in the flow itself within the flow definition if a processor is doing something wrong, and so on. So that's really what built-ins are for. And a built-in, as you can see, I mean, you noticed it here, the built-in disappeared. A built-in is only staying in the UI for 5 minutes. And for a given component, we keep only up to 5 built-ins for a duration of 5 minutes. So the next question is, okay, great, but unless I'm in front of my UI all the time and I'm clicking refresh, I want to know when there is a built-in generated. And that's a very good remark, and we are going to get to that because being alerted every time there is a built-in in NiFi is probably a very good idea when it comes to monitoring NiFi. The other one I wanted to talk about is the memory reporting task, which is kind of similar but for the memory, and we are looking at the usage threshold for the memory. So yeah, that's what we have by default if you are deploying NiFi with Cloudera. If you are not using Cloudera, you would have no reporting tasks by default, and it's really up to you to add the reporting task and configure these. Okay, that's great. The next step is to be alerted in case something is going on. And there are many ways to do this, and given what time it is already, I just want to mention very quickly right now that there is a a lot of monitoring dedicated blog posts on my website. And in particular, if you look for monitoring, there is a couple of blog posts I will be recommending. There is this one, and I'm going to copy the link in the chat. As you can see, it's 3 years old, I should spend more time doing blog posts, but it's taking too much time. But this is a very useful blog post, and I think almost all of it is still very valid. A lot of things have been improved in the last 3 years, but it still gives a very good idea of the approach that one should follow for monitoring NiFi. And then you have other monitorings like some specific monitoring patterns for flows, and there is, if I recall correctly, there is like a main monitoring. Let me. Well, never mind. If you go to this this one, yeah, okay. So here you have this monitoring NiFi introduction where I'm talking about site-to-site reporting tasks, built-in alerting, etc. So I'm going to copy paste this. It's even older, so hopefully all of it is still very accurate, but yeah, as I said, we improved many things. Topics around monitoring is something I really like to talk about, so if you have questions, feel free to ask your questions. A lot of things improved over time, so yeah, everything may not be fully accurate, but I think this is still giving a good idea. So yeah, so the next step from here is to look at the to look at the reporting task you have and check if there are reporting tasks you may want to consider. So I will share with you some of my favorite reporting tasks because I think there are 3 or 4 reporting tasks that should be used in any NiFi cluster. So we will be showing the Prometheus reporting task later today. So this is something I will be showing. QueryNiFi reporting task is a very useful one, very useful one, and we are making improvements on this one to make it even easier / better to use. So this one I will get back to it. You have scripted reporting task, which is super useful in case you have very specific needs and you don't want to develop your own reporting task. You want to access the data made available by the NiFi framework and use this data in a very specific way using some scripts. That's an option. If you are using the scripted reporting task, I would love to know more about this because maybe we want to make this something available out of the box instead of having you scripting something very specific. And then we have the site-to-site reporting tasks. And the site-to-site reporting tasks are super useful and super powerful because it provides a lot of flexibility. So site-to-site is initially, at the very beginning, site-to-site has been developed to, let's say, share some data back and forth between different NiFi deployments. Like you have a NiFi cluster in your data center A, you have a NiFi cluster in your data center B, you want to exchange data between the 2 NiFi clusters back and forth in a very efficient way, you will be using site-to-site. But now site-to-site can also be used to inject data from NiFi directly into NiFi. So basically what the reporting task with site-to-site are going to do is to take some of the data that the NiFi framework is generating and injecting this data as flow files directly into NiFi. What it means is once you are using the site-to-site reporting tasks, you can use any processors you want to do whatever you want with this monitoring data. So this is really powerful, this is really flexible because just like that, you can get access to the data generated by the framework and do whatever you want with it. You can send it to HDFS, you can send it to Kafka, you can send an email if you want. You can use HTTP calls in case you want to open a case automatically in your I don't know, ServiceNow, Jira, whatever ticketing system you are using. So this is really powerful and it gives you a lot of flexibility. So something I will be recommending is to look at the side-to-side built-in reporting task, and how you configure it is quite easy. The first thing you need to do is usually to drag and drop an input port where the data is going to be injected. So if we follow the good practices, what I would recommend is to have a dedicated monitoring process group. In this process group, I'm going to drag and drop an input port, and I'm going to say to call it S2S input port. I'm going to copy this. I'm going to say that this input port is used for site-to-site, and I'm going to add it. And then I'm going to add just, well, actually, let me add a funnel just to do nothing, but at least so that I can start this input port. So now I have this input port available, it's running, it's available to receive some data, and I can configure my reporting task. So if I go to my reporting task here, I can configure my built-in reporting task. So the first one is destination URL. So in some cases, you may want to send this information to another NiFi cluster, and that's perfectly fine. You could have like a NiFi cluster dedicated to monitoring for many other NiFi clusters, or you can just re-inject the data in the same NiFi cluster and just do that. That's what we are going to do in this case. So in this case, I don't want to hardcode a value, so something I can do is to use expression language, and I can use hostname with a full qualified name. By default, it's listening on this port, and I think that's it. I don't remember if I need to add NiFi at the end. Yeah, I need to add NiFi at the end. Okay. So here, and then the input port name that I created, and since my cluster is secured with an SSL, I need to provide a context service, SSL context service, with my key store and trust store. If you are using NiFi with Cloudera, we are creating one automatically for you with everything configured with the key store and trust store, so you don't have to go through all of this. You can just use this one. Okay, and this I'm going to copy paste it here. The instance URL is just some information that will be part of the payload sent as flow file, but you don't need to really worry about it. In terms of protocol, we use HTTP, because if you want to use raw protocol, it's the same. So basically, it's just, do you want to use TCP over TLS or HTTP over TLS? Using HTTP is easier because it's going to use the same port as the one on which NiFi is listening for the UI access. But if you want, and if you can use raw access, and you need to specify a specific property in NiFi.properties to tell which port NiFi should use for raw communication. The only thing you need to keep in mind is, if you want to use raw, then you need to update your firewall so that you can have communication for this port. But in this case, I don't want to worry about security groups and firewall and stuff like that, so I'm just going to use HTTP, and that's fine. You could just do that if you want. What I recommend is to configure a record writer so that the data is going to be formatted in a nice way. And in this case, I can create a new service, and I say that I want my data in, let's say, JSON. So I'm going to rename this because I like to rename it this way. I'm going to use JSON. and that's it. And I can click apply. It still shows invalid because there is a hold on, what? Oh yeah, I don't know how to write correctly. Okay, so here we want to close the expression language. So here and here, apply, and it's going to still complain because my record writer is stopped. So if you go here, you have the controller services dedicated to the reporting task, and I see my JSON writer that I just created. I can enable it. I just want to keep the defaults. If you want, you could go into it and change a few things, configuration and so on, but the default is fine. And now I can start my reporting task, and I can start it, and now it's running. And every time a built-in is going to be generated at the framework level or by anything in my flow, I'm going to inject all of this information and receive it as a flow file here. So to simulate this, what we can do is actually use the generate flow file and the update attributes. So something we can do here, if you want to simulate a built-in, this is very easy. You go to a processor, and here you can see there is a built-in level, which by default is always set to warning for all of the components. But if you want, you can set it to info. And if there is a log level in the processor code that is at info level, then it will show a built-in. In this case, this is a bad example because I don't think update attributes is one of these processors. I'm going to try, but otherwise I will be using another processor just to simulate a built-in. Let's try, but I think, yeah, it's not logging anything, and this is for a good reason. So let me take log messages. Log message processor is a better fit in this case because this processor is supposed to log stuff. So in this case, I can go here, say info for the log level. You can see it here. That's fine. And I'm going to terminate the relationship so that the processor can be started. So okay, now if I start generating some data here, I run once, it's generating a built-in. And here we can see it. I have a built-in that has been generated on all nodes. Well, there is no data to... so this processor is really about logging whatever is the content of my flow file. But in this case, I have empty flow files. So it's just to simulate built-ins. But you could have more meaningful information here in a real life scenario. So here I have 3 built-ins that have been generated because it's on all nodes. If I want to simulate, if I want to simulate generating a built-in on just one node, I can change here the generate flow file to run only on the primary node. You can see it here with the small p letter. And if I run once and refresh, I can see here that now I have the details because I have a built-in that is specific to one node. Which is node NiFi 2. As I said, this is my primary node. So we see the 3 built-ins, one per node, and then the other one for the NiFi 2 node. Okay, that's great. And depending on how frequently your reporting task is executing, you should see some data landing here. But I have some permission issues. And that's because you need to set some policies. Because by default, we don't allow site-to-site. So, I'm going to show you how to change policies when using Cloudera. So this is done with Apache Ranger. If you open Apache Ranger, this is a very nice project from the Apache Software Foundation where you can manage all of your policies in one place for many components. So in this case, I'm going to go to my NiFi cluster. These are my policies by default, but I'm missing some properties allowing NiFi to send data inside to site. And if I go in the audits and if I filter on results denied, I would see here that my NiFi nodes are denied
access to site here, as you can see it. So I need to create the policies so that my NiFi nodes can actually send data over site to site. So this is something you will need to think about when using site to site with a secured NiFi. If you are not using Ranger, you would do it at the root process group. You will go here in the policies, and here you could select receive data via site to site or send data via site to site. You could see it here. But in this case, since I'm using Ranger for managing my policies, I can't change the policies using the NiFi UI. This is one or the other, but not the two at the same time. So I'm going to create my policies here. So let me go back to NiFi. Sorry about that. So I'm going to create a new policy, site to site, and this is site to site, and I'm going to use my NiFi group, which is representing all of my NiFi nodes, and I'm going to grant all permissions. So that's the first thing you need, but that's not enough. I mean, we can see it. If I go back to the audit logs, and if I filter on denied, right now we see site to site, and I can also filter on my NiFi cluster here. So right now we see that the NiFi nodes are denied the access over site to site. This is the first step, but that's actually not enough. And if we wait a bit, and that's, let me generate some additional data, we would have another deny, because actually you need a combination of two policies, and I just want to show you this whenever this is showing here. But basically what you need to add as well is a policy allowing you to send data into a specific input port. So there is a specific policy you need to set. Let me find again the exact syntax, because to be completely honest with you, this is not something I know on top of my head. That's yeah, that's the one. Yeah, so yeah, so what you want, so let me refresh here just to see if we have the new deny. No, we haven't. That's all right. Let's create the policy. It will be fine. So we need to create a new policy, which is about data transfer. So site to site is one thing. This is about being able to, let's say, check for the nodes in the remote cluster. This is really just allowing site to site communication. But then you need a policy to really allow for data transfer. So in this case, we are going to say monitoring input port, and I need the input port ID here. So I'm going to copy paste this here. So this is data transfer, and this is the, well, actually this is the one. The autocomplete is really nice. So that's the one, and I want to give this to my NiFi users, NiFi nodes, because in this case it's really about the NiFi nodes of the within the cluster to send data to itself. And I'm going to add this policy, and now it should be better, and I can run once to generate another built-in. If we go in the policy here, now when the policies are synced, we should see the policy here. But basically, that's really what I created in Ranger right now. So just something you may want to consider. Yes, everything is ending on YouTube. Yes, I will upload the video later today or tomorrow. But yeah, it will be on YouTube either today or tomorrow. Yes, and thanks for joining. So yeah, so something you may want to consider is how frequently the reporting task is running. By default, this is every minute. So this is fine every minute, but something to keep in mind depending on, I don't know, your requirements. It means that you may be alerted about something going wrong in NiFi at most 1 minute after things really happened. So yeah, that's it. Now we have data available here. So this is the data about my built-ins, and I have all of it. So if I list the flow files there, and I look at one of the files, and I click view, and I format it because I want to read it, we have all of the information about the built-ins. And you can see that I also have built-ins related to the side-to-side built-in reporting task not working, which is kind of funny. But I also have the built-in related to what I generated for simulating errors. So you see that there is a lot of useful data here. You have very interesting data. Like the group path is something useful. So it will be the path of all the process group where the processor generating the built-in is located. So if you have like a multi-tenant environment with a lot of process groups for each team and each use case, this will give you information about where the processor is located. So this is something I'm talking about in my blog post. You may want to do some filtering based on this, and then well, if the built-in is related to a flow belonging to team A, well, you may want to send an email to the team A. If the flow, the built-in is coming from a processor belonging to team B, you may want to route the built-in and send it to team B. So this is a way of making sure that the right people are alerted for things that they should be aware of. That's something really useful. So you have the processor name, you have the process group name, that's useful. You have the date, obviously, you have the built-in message. And we are also working on something that is going to be added in the future. It's going to be the flow file UUID, which is something super useful. So just to give you, let's say I am the guy. Sorry, it's been a long day. I am the guy receiving the alerts because I'm working. I'm within the team A. I'm working on my use case, and I receive this built-in, and that's great. But I want to, well, I want to do something about it. I mean, that's great, but now, what is it? What do I need to look at to really figure out what happened? Because in this case, we know that we had an alert, but we don't really know which flow file, which event specifically caused this error. And that's something very important. So this is something we are adding right now. There is a pull request for this upstream, which is being reviewed, and hopefully something that will be merged in the coming, let's say, weeks. Is the addition of the information of the associated flow file. So be careful, there is not always a flow file associated to a built-in. Like, I don't know, there is a Kafka processor trying to consume data from a Kafka cluster. If there is a network issue, there is no flow file. It's just the Kafka processor cannot fetch data from the Kafka topic, so there won't be any flow file information. But in this case, the log message processor generated a built-in following a flow file, the processing of a flow file, and right now I don't have this information. So if, as of today, if I'm the guy receiving this information, I need to debug it. what I will be doing is, well, the first step is go to the processor. So if I go here, I can copy paste this. Okay, and in the search bar here, I can paste this and I get the information that I'm looking for. So I know this is the bad guy. This is where the issue happened. Obviously, I don't see the built-in anymore because the error happened maybe during the night, but I still want to, well, check what happened. So now I know this is this processor that caused the issue, and something that you will probably want to do is look at the data provenance. So the data provenance is something extremely useful in NiFi. You can't underestimate how useful the provenance data is in NiFi, and this is something that is not used enough by NiFi users. The provenance data is a very powerful tool in NiFi, something that you can use in many situations, and something that unfortunately is not used as much as it should. And we probably need to improve awareness and user experience around the data provenance, but this is something super useful. So anyway, I will probably make a dedicated live session about provenance because this is something super powerful, super useful. So in this case, I have my processor, I know where the issue occurred. Now I'm going to look at the dates. The built-in timestamp is at this date. So I'm going to check for the same date. So, okay, so this is probably this guy, because this is the same timestamp here. So I know this is this guy that generated this built-in. So I'm going to look here, and I have some information about the flow file. I mean, in this case, this is a provenance event. You can see it here. This is the provenance event, but I can have some information about the attributes. What were the attributes of the flow file? What was the content before and after going into this processor? Well, in this case, I'm just playing around with empty flow files, so there is no content, but you will be able to see the content before it goes in the processor and the content of the flow file after being processed by the processor. So this is super useful. And I can also look at the lineage, which is also something super useful. Well, in this case, my flow is super easy. It's just, well, one generate flow file, one log message. So there is not much to see. I can see that my flow file has been created by the generate flow file processor. I can have some information. This is useful, but sometimes, depending on the flows you may have huge lineage here, and this is super useful. You can also check the time and see when things happened, if some very specific let's say places of your flow are taking longer, if there is a bottleneck, things like that. So this is super useful. Something I can show you something that would be a bit more meaningful, I guess, in terms of lineage, is if I use merge content. Yeah, sorry, I need to stop this first. Okay, just very quickly, because provenance is something super useful. So I'm going to generate some data here. This is my data, and I'm going to create some next int here. So I'm going to generate some interesting data, and here I'm going to generate here texts here. So I'm going to append the data one after the other. Minimum number of entries 10, and that's it. And I need to auto-terminate fader and original. And okay, so now if I start this and I start this just a couple of times, just to show you things, how it works. I can stop this, refresh, and start this. So I have new built-ins being generated, I will get the information, etc, etc. But now if I look at the data provenance of this, so now I have something super useful. So I can go into here, I have the attributes, what are the attributes of my flow file. I can see the contents before and after this processor. Obviously this processor log message is not touching anything in the contents, so this is not something useful. But something super useful is the ability to replay the event. So if there is something wrong that happened for a given flow file, I can go into the provenance data, I can say, okay, let me stop this processor, let me go back to my data provenance. Okay, I want to look at this. Okay, content, great, maybe there is something wrong, I want to look at it again, so let me do replay. I'm doing replay, this is going to replay the event, and if I refresh, the flow file is back here. This is super powerful to manage debugging, failure handlings. I don't know, something happened during the night and you want to run again some events. This is super useful, and that's why correctly configuring the provenance repository is so important. And so now I can list the queue, and I could be looking at this specific flow file. Here I have my data with all the ideas. So that's great. But if I want to go one step further, I could go here. So I see the replay event now, but let me go back to this one and now show the lineage. And here, okay, so we see that I have replayed this event, which is super important for everything around audits. Make sure that you are auditing whatever is happening for a specific event. So in this case, I want to see that I replayed this event. But now I want to find the parents. Well, in this case, I'm merging a lot of data, so it's not going to be showing what I want. So sorry about that. So let me actually empty the queue and merge smaller amount of data, because in this case I'm merging a lot of data together. So let me take like merging 50 flow files together. So run once, refresh, start here. Okay, so now I have new data provenance here, and I can look at the lineage to show you really what's happening. So in this case, I can see the drop, but here, if I right click on the node, I have some information. So I can find the parents, and in this case, I can see all of the flow files that have been used to create the merged elements. So if I move a bit, well, this is quite a lot of data. As I said, if you have very complex flows, it can make very huge pieces of information, but this is super useful. So in this case, I have all of my flow files that I created, 50 of them, by the generate flow file, and all of these have been into this merge content processor, and we can see all of the information, all of the flow files that we used, and the child flow file created from the merge operation. We have the information, we have the attributes, content. Obviously, we can't show the content before because this is coming from many files, from multiple parents, but you can see what has been created. You can look at the flow files, that's great. And here you can see that all the originals were dropped because I auto-terminated the original connection. So these are the originals, and here on the far left I have my merged element that went to the log message processor. So yeah, so sorry for this little explanation, but provenance data is really something that you should be aware of. Replaying events is something so useful in NiFi. So yeah, you should be aware of it. So yeah, so that's what we have with the built-in reporting tasks. If you want to be alerted, so something you may want to do, as I said, will be to do something like partition record is something you may want to consider. That's what I was saying. So you can split each built-in depending on which team is concerned by the built-in itself. That's up to you. And then you could have like I don't know, a put email processor where you are sending the built-ins to some people depending on what you want to do. So that's an option. Obviously, you can also use other options. So this is really what you can do with reporting tasks. And sorry, controller settings. In the reporting task, you also have very useful information. So I'm actually going to show you the kind of data you have with the other reporting task. So let me add provenance one. Provenance one is super useful in case you want to build, let's say, monitoring dashboards for job-like flows. Like you want to, I don't know, you want to process, to extract some data from a database once a day and push this information into another database. And this is a process, this is a flow that you configured that is running once a day. And you want to build a dashboard to show when it ran, how many records you extracted from the source database. I don't know, validate the records and show how many records were valid, how many records were invalid, and then push this data into another database and see the number of records successfully sent into the last database. Well, this is something that you can easily achieve using a site-to-site provenance reporting task, because all of the provenance data I was showing before is something that will be injected as flow files using the site-to-site provenance reporting task. And this is something you can then use with I don't know, you could have like here you could have a PutSQL processor that is going to execute a query to inject specific pieces of these provenance events into a database where you want to build your table to follow and track what happened in NiFi. This is something very easy to achieve. So that's the provenance reporting task. If we go into the documentation and go into additional details, this is the information you have for every single event. What you want to probably look at is updated attributes and previous attributes. So basically, what are the attributes before and what are the attributes of the flow file after it went through the processor. This is something useful. And lineage start is also something useful because that's how you can, let's say, compute some SLAs on how fast a single event has been computed or processed within NiFi. So let's say, I don't know, you have a flow starting with Kafka doing a lot of stuff, and then the data is sent to HDFS. If you look at the provenance events for the HDFS processor and you look at the lineage start, you would have the time of when the flow file has been created when consumed by the Kafka processor. And this information is really about how long it took in NiFi to process all of this data and make it available into HDFS. This is a very useful metric. This is something you may want to have like in a Grafana dashboard, and this is something we will be showing. Okay, cool. That's great. I don't know if what I'm saying is clear. I'm checking if there are questions. Not much. I guess it means that what I'm saying is relatively clear. But let's keep moving. So that's the one for provenance. There is one for metrics that's particularly useful if you want to build some stuff based on what's happening in terms of amount, let's say the amount of data being processed. So if you look at the documentation for this one and additional details, and if you look here, you have this kind of information. So every time the reporting task is going to be executed, it's going to take a snapshot of all the metrics we have at NiFi at this time. So you will have information for each processor, each connection, things like that about, actually, no, this is the next metric. This one is just a snapshot of the system level metrics like GVM, flow files queued, flow files sent, received over the last 5 minutes. So this is a high level node level metrics reporting task. The one I was thinking about is actually the next one, which is status reporting task. Status reporting task is the one I was talking about, where you can have information. So every time this is running, it will take a snapshot of everything that is happening in NiFi at this time, and you will get some information for every component. So let's say for process groups, you will have these fields. For remote process groups, you will have these fields. For connections, and that's something super useful. You would have these metrics, and something that is super useful in this case is back pressure enabled. And if the back pressure is enabled on a connection, well, that's probably something you want to be alerted for, because back pressure in a connection is not going to generate a built-in unless you want to do it. But using this reporting task and filtering on is back pressure enabled, this is going to allow you making some alerting based on this value specifically. So that's super useful. So these are the site-to-site reporting tasks, and all of them are super useful. The next one I want to talk about is QueryNiFiReportingTask, which is also super useful, and then I will switch to Prometheus and Grafana. I'm taking more time than expected, but I'm used to it. It's always like that. Feel free to ask questions also. I mean, I feel like I'm just talking and not necessarily talking about things that are interesting for you. Let me know if I should go faster or take more time on specific subjects. Yeah, so QueryNiFiReportingTask is something super useful. This is a reporting task, which is basically allowing you to write SQL queries over the data that is made available by the NiFi framework. So that's something super useful. So basically, this is one step further, I would say, in terms of what the site-to-site reporting tasks are providing. The reason why I'm saying this is that in this case, you can write a SQL query on top of some of the data we talked about: connection status, processor status, the built-ins, process group status, etc., provenance data, etc. And then you can decide where to send this data by defining a sink. And you have many sinks available. You have Kafka, you have logging, because many users of NiFi are just logging stuff in the NiFi logs and using tools like Splunk, ELK stacks, and things like that to collect these logs and send it somewhere and build dashboards. That's perfectly fine. That's not how I will do it because I think there are much better tools to do this. But that's something you can do. So Kafka sinks. You can also send to multiple sync at the same time, which is really great. If you want to send to multiple destinations at the same time, let's say you want to send to a database, you want to send to send some questions. Oh, great, thanks. Thanks, Max. So you can send this information into multiple destinations like Kafka, logging, database. Database is what I was talking about before, because before I was saying, well, you may want to use like site-to-site provenance reporting task, and then use a PutSQL processor to send this data into a database so that you can build a dashboard, a table of what's going on for batch-like flows. In this case, you can just write your SQL query to select only the information you want and send this using the database record sync, which is super useful. So yeah, this is really powerful. Something that you may want to do, for example, is well, let me show you an example or something that can be useful. So let's say I want to generate a built-in every time there is back pressure enabled. Yeah, that's something I'm going to talk about. The Prometheus endpoint. Yeah, that's a very good question. I will get back to it in a minute. Actually, once I'm done with the QueryNiFi reporting task, I'm switching to Prometheus. What I was saying. Yeah, so let's say I want to generate a built-in when there is back pressure enabled. What I want to do here, so actually I'm lazy, so I'm going to go into the documentation, go into additional details, because that's where you can find some very useful information and some examples. And basically that's super useful. So let's say here, well, that's actually super useful. You can select connection status predictions to know when back pressure is going to be enabled in a given time. That's super useful. In my case, I'm not going to do this. I'm going to just check for when there is connection status. Where is it? Connection status here. And I'm going to check for is back pressure enabled. Okay, so I'm going to do that. I'm going to write a query saying that I want all of the information from connection status, where is back pressure enabled. Yeah, true. If my SQL stuff is correct, that should work, hopefully. And in this case, I can create a sink. And in this case, just for the demo, in this case, I'm going to use a logging record sync, which is fun because you can actually start doing some very fun stuff. So I'm going to configure this controller service, which is really about logging. And here in this properties here, you can define the record writer. So I'm just going to use the JSON writer. But here I'm going to say 1. And because it's 1, this is going to generate a built-in. So this is how you can configure something to generate a built-in when there is back pressure enabled. And then you can have whatever system you configured for the built-in. So let me enable this. And the reporting task now here can be started. And that's great. So this is also running every, well, in this case, every 5 minutes. So I'm going to force some back pressure here because we are close but not full. So start here. Now we have back pressure enabled. I'm going to stop this, and if I go back here, I'm going to stop my QueryNiFi reporting task because I don't want to wait for 5 minutes. So just going to start it again now. And in theory, it's looked for is back pressure enabled? Yes, I have a connection where back pressure is enabled. So I'm going to send this information to my logging record sync. And I said that I want this information to be logged at a 1 level, and everything above 1 level is generating a built-in. So this is generating a built-in. I have a built-in here, and now if I go into my monitoring system, and if I look here, and I list Q, and I look at my the latest flow file here, and I look at this one here, formatted, I have the information about my Q here. So now I generated a built-in when there is back pressure enabled, and I can use side-to-side built-in to actually do something about it if I want, and I have some information about the Q, etc. So it's a JSON inside the JSON. This is not the most let's say, this is not really what is super fun to process going forward, but at least this is a way of generating a built-in when a full is Q. And by using the same table but using the connection predictions, you can generate a built-in when you are about to get a back pressure into a connection. So you can generate a built-in before back pressure is actually enabled according to some custom thresholds you would like to define. So this is kind of mixing stuff together, but you can see how by playing around with many things you can get very powerful stuff. Sorry about that. So I will take the questions, and then I will switch over to the Prometheus stuff. API endpoint /flows/metrics, and now we have Prometheus. Do we have others? That's a very good question. As of today, if I recall correctly, there is Prometheus, and I think another one. Let's check. Search /metrics. I think that's I don't remember exactly what's the name of the file. I just remember let me get the information. I know I have it here. It's been a while since I went into this part of the code, but I know I have it here. This is on another screen, but actually, yeah, I don't remember which class this is exactly. Well, I thought I had it, but maybe not. I know this is somewhere in the file. Let's do it differently. If I'm looking for Prometheus, this is a way of how to find stuff in a GitHub repository, and sometimes this is fun. So this one, and then 12 changed files, and that's, I think, the one I'm looking for. I think this is this is the one. Yeah. Yeah, so this is the one here in this code. So let me go to this file, flow resource, okay, view file, And if I go to the main branch, okay, Prometheus. Okay, so yeah, so right now this is the endpoint where you can get, I mean, you can configure Prometheus to go scrap some of the data. In this case, I'm not sure this is exactly the one we are looking for. I think it is. But in this case, you can see that we have only Prometheus as of today. At Cloudera, we are working on another one right now as we speak, to actually better integrate NiFi into the Cloudera Manager UI. This is something we are working on right now. So if you go to your NiFi cluster and if you open Cloudera Manager UI, and if you go to your NiFi service, we have some information, but not that much. And we are working on exposing another endpoint that could be used by not only Cloudera Manager, but Cloudera Manager will be one of them. Because the issue with Prometheus is that it's using a very specific format on how the data is exported and exposed. I mean, if I'm calling this API myself through my browser, it's in a very specific format, very dedicated to Prometheus. So we are working on another format that will be like more friendly, like JSON, that could be used by other stuff like Cloudera Manager, but anything basically. So that's something we are working on. This is something that should happen like before the end of this year. But right now, to your question, there is only Prometheus. Taking another question, can consider for future session if running out of time. Yeah, have a few flows for which I want to see provenance along with attributes. Yeah. This is kind of understand what you are saying. That's actually there is actually a lot I would like to improve in the viewer for the provenance UI, and that's why I'm saying that we are probably not doing a great job at making it super user friendly. So what you are saying, I guess, and let me know if I get what you are asking correctly, because maybe I'm thinking about something and this is not what you are talking about. It's basically, if we go in the lineage here, what you would like is like, if I go over this node, you would like to see the attributes before and after, instead of doing view details, go into the attributes, view details, go into the attributes. Like, you will have a view that is more friendly, where you have the changes of the attributes on all the lineage, so that you don't need to go into each step and look at well, basically, if I say it differently, you would like to easily see where an attribute has been created or added to a flow file. And one way of doing this will be to have this view. Oh, about the grid, okay. So then I'm not sure I understand. Oh, okay. Sorry. Yep, view data provenance. Yeah, so you would like to see some kind of attribute information from here. That's what you are saying. But yeah, in that case, I mean, you can have many attributes for a given flow file. So I'm not sure this would be super easy to show things here. Something that you may be interested in, and to be completely transparent with you, this is something I never tested, but yeah, okay, that's what I was going to talk about, and I was going to mention it. Okay, so this is something I well, just to explain what you are talking about. So there is something in NiFi. If you go in the NiFi properties and here, when you go to the provenance here, you have here the list of the attributes that should be indexed and made searchable for the provenance data. And I assume that this is what you are talking about. And in some cases, for some use cases, you want to index specific attributes. If we go back to my NiFi cluster, let me switch again from here. Sorry, this is kind of not fun. Next time I will be better prepared on this. So let me go back here, and if I go to this okay, and if I do this, so by default in NiFi, we can see here that we have the indexed fields. So these are the fields related to the flow files, not the attributes. Sorry, just give me a second to remove okay, here how I delete a message. I'm sorry, I'm learning about this. Okay, I guess. Okay, yeah, here it is. Sorry, I guess I was supposed to expect it at some time to have some kind of people coming on the chat and posting some stuff. Anyway, sorry. So I don't have a moderator yet on my Twitch live streams. Maybe it will come one day. Anyway, so yeah, by default we have these indexed fields. These are the things we have for the provenance data. And someone, by default we don't have anything, but someone may want to have specific attributes indexed here. And what you are asking for, I guess, is for a way to see this information in the provenance table we were showing before, right? Do I understand it correctly? Going back here. Yeah. Okay. Cool. So yeah. So this is a very good. This is a very good question. I mean, this is something totally legit. There is no way of doing this as of now. And in the past, I did change a bit of the code around tables in NiFi, and I'm not sure how flexible this will be. I will need to have a chat with the team working on the UI UX. But in your case, I'm just curious, because this is actually a very interesting subject. How many attributes are we talking about? Like, I mean, assuming you are indexing like 10 attributes, this is going to make the UI not look great. So I'm trying to think, are you talking about a very small number of attributes that are very important to you, to your use case? Yeah, okay, 4 or 5, okay. And what would you expect? Like, for provenance event, you would expect only the well, in this case, this is not a good example, but like if I show the data provenance here, and I look at this, for example, here, we see that we have the attributes before and after. Like we can show only the modified, and we can see the value before and the value after. So merge UID, we didn't have a value before, and we have the new value. Would you want to display only the new values, or also before, after? Or it's just about, yeah, it's just about showing the new values? Because yeah, it can get, yeah, okay. I guess it could get quite big, but that's a good question. I will actually, I'm interested by this topic, because that's something I was considering at some point, and that could be something nice. I agree. Okay, cool. So right now, not possible. Definitely something that would be useful. Feel free to file a Jira upstream. Maybe there is already one, but feel free to file a Jira in NiFi. That's definitely something I will be discussing with the UI UX team, because it could be it could be something interesting to add. Because as I said, provenance data is underused in my opinion, and yeah, I guess this could make it much more attractive. If you can file a Jira upstream, that would be awesome. At least I'm sure I don't forget it, and you say it with your own words, and I'm not changing the meaning of what you are looking for. Just scrolling back a little bit, is it possible to get the last time when a processor was running? I have the feeling our devs have a lot of process groups which are outdated. Would be nice if it would be possible to get the time and clean the UI a little bit. For example, when a processor is unused since 6 weeks. Not really. So something you may want to consider, but I'm not sure if this would work in your case, is that's a good question. I never I never considered this question before, but flow configuration history is something where you can see what happened on what happened basically in the flow configuration. This is so this is useful. You can see if configuration changed. Like for example, here I changed the configuration. So I changed the value from from info to 1 for the property log level into my component logging record sync. So you have all of this information, and I mean you can see it's so it's going back to well, the beginning of the week when I created my cluster. So I guess this information is I mean, I'm sure this is persisted on disk, but I guess this NiFi flow history is something that is let's say that is kept in memory until you restart NiFi. And something you could do is like, okay, this processor maybe hasn't been used for a long time. You could look at this specific processor UUID and go flow configuration history, and you could filter on a specific ID, and you can see what happened for this specific processor. And if you see that it hasn't been used for like 6 weeks, assuming this data is staying there for 6 weeks, you could remove it. That's how I would answer your question, Max. I think it was from you, yeah, Max. That's how I would look at this. that's something you should check on your side. I'm not sure about how long we persist this data, and at least in the UI, I know on disk we have like a lot of the history and so on. I'm not so sure about how much data we keep for this, and it's probably dropped after a restart. I don't know, I'm not sure. So yeah, definitely a good question, and probably something you may want to check on your side. Let me know next time if you are able to give this a try, and if it's not great, then I guess we can look into it a bit more. The question I will have is, we can't really do it at the process group level, so not so sure this will be super useful, because if I'm doing this, then it's a process group, but I just have the creation of it. I won't have the history of what is happening within this process group. So we will need probably some improvements around this. So yeah, that's one way of doing it as of today. Not the best option, but that's the only one I have in mind right now. Okay, very quickly, I just want to go through the Prometheus stuff very quickly, and this is the last thing I will be covering, because we are already over 2 hours of live. But I just want to show you very quickly how we can set up Prometheus and Grafana, because I think this is something useful that should be done for any any decent deployment, because you can build very powerful dashboards without doing much, in my opinion. So let me show you how it works very quickly. And I'm going to copy paste a lot of things I have done in the past. So sorry about that, but yeah. So let me switch over again to the console. Okay, so one sec here, change, and this is the right one. Okay, so I'm back here. I'm on NiFi 1. That's great. I'm going to connect on all my nodes. So hold on just a sec. I'm going to connect on this guy as well. That's not what I want, sorry. Okay. Okay, so that's my management node. That's where I have my NiFi registry configured. So I'm going to move this here, and then I'm going to connect to all of my nodes, my NiFi nodes, so that we can do our stuff on all of the nodes. So I know how painful this can be to watch someone typing in a console, because we all have different ways of doing stuff, and I know that I'm definitely not doing it in the most efficient way. So bear with me. I could probably do it in a way more efficient way, but yeah, well, I'm doing my best, so it's not too boring and too annoying to watch. But really, I just want to go quickly through the steps I did to have everything set up. So I will just move this here so that I have NiFi 1, NiFi 2, and my management nodes. So okay, so now I'm going to just do the steps to deploy my stuff. So let me find my notes. So the first thing I want to do is to change something that is very Cloudera specific. And just so you know, this one is not really required in this case, but by default, here we see that we already have some node exporter stuff that is available on the NiFi nodes. This is set by Cloudera. This is how Cloudera Manager is also collecting some information about the nodes. This is super useful, but in this case, the Cloudera Manager agent is running on the same node and is going to get this data. And that's why we are listening only on the local interface. That's not something I want, because in my case I want to have a Prometheus setup and I'm not using the Cloudera Manager agents. The node exporter stuff is super useful, so I'm going to just edit this file and remove the fact. Oh, sorry. Yeah, I'm a Vim guy. Sorry about that. And I'm going to remove just this to listen on all interfaces. So I'm just removing this super quickly here. This is very specific to stuff already running on the nodes. So in this case, it's just that there is a plugin that is node exporter that is, maybe I'm saying it wrongly, but sorry, but node exporter is basically something that can be used to export the node level metrics to Prometheus, and that's super useful as a first step. So that's why I'm making sure that we have this, and then I'm going to restart node exporter on every node. So that's something we already have. I'm not going into too much details around this. And then that's all we want on the NiFi nodes. Now I'm going here, and the first thing I'm going to do is actually to download Prometheus. So I'm sorry, I'm reusing the version I used a few months back because I don't want to change the versions and so on. If there is a more recent version, actually, let's do it properly, because I know you guys want to do this properly. So let's do it. So I was using an old version, and let's take the last one because we want to do this the right way. So let me find the latest version. This is the one I want. So here we are downloading Prometheus. Okay, so when I'm saying we are going to do it the right way, just one small detail though, I'm not going to set up authentication and authorization on Prometheus and Grafana. Yeah, that's not the objective. So this is something I'm not going to do. But yeah, just so you know, I'm taking the latest version for Prometheus, but I'm not going to do any specific stuff around authentication and things like that. So I'm following exactly some steps I followed in the past to install it. So I'm sorry if this is not exactly what you have in mind, but I'm going to follow the same steps. So I'm going to do that. And then I'm going to add some users dedicated to Prometheus. I'm going to create some data where Prometheus will store the data. I'm setting the right permissions. This is something we could automate in a script. I'm not that good. So that's it, and now we have Prometheus here. And basically we have Prometheus up and running. So that could be it, and we have Prometheus running. That's great, but I'm going to create a file for it. So I'm going to create a system. Oh, I already have it. I'm just checking if I have everything I want. No, I don't. So I'm actually going to remove this. Okay, let me copy this. And here I'm going to, oh, sorry, add this. Okay. So I don't want to go into too much details here because really this is about installing Prometheus, right? So I just want to have things up and running. So I'm just going to, sorry about that, here. Okay, and enable and start. Okay, so now if I look at Prometheus, should be up and running and it's listening, and that's great. Okay, that's cool. And I'm going to now get Grafana. I'm reading some stuff at the same time and I'm getting confused. So what's the latest version of Grafana? Download. And I need to register. No, I just want to download self-managed. Here, download Grafana. Grafana, I mean, they are doing a great job. I mean, I'm always really impressed by everything they are doing. This is really great. So the last time I did this, I was using version 7.4, and the last one is 8.2. So let's go with that. I hope I won't have like something weird, but we'll see. So I can get this, and then this. Okay, so we are installing everything. Okay, and then we can have this. We can enable it so that it started in case of a restart, and we can check for the status. Okay, that's working. So now that's great. I'm just checking if there is something I wanted to mention. So yes, there is. Here there is the node exporter rule that I want to create, which is not created. So I'm going to create this. So this is something you can get on the internet. This is the classic job definition for node exporter in Prometheus. So I'm just taking this. I can share it in some GitHub files or in the comments description of the YouTube video I will be posting. So that's fine. But now I guess what we want is to access the UI. So I don't know, I don't remember on which port Grafana is listening by default. So it's listening on 3000. I guess that's the one I want. Yeah. So I'm going to open the required ports in my security group right now in AWS so that I can access the UI and we can start building some stuff. So just really, it's just to show you how quickly we can get to something really useful. So just give me a sec. I just want to open the security group for me. So I'm just doing this very quickly and I get back to you in a minute. So I'm just going to open the port. That's really what this is about. Obviously, since I didn't set any authentication, I don't want to open it to the world. So I'm going to add a rule, custom TCP 3000, and only for my own IP. Sorry guys, I'm not going to give you access to Grafana, not just yet. Okay, so we will get back to the console in a minute, but basically if I just show you now what it looks like here, and if I copy paste this now, and if I go to HTTP this on 3000, I should have, I don't want, why is it switching automatically to HTTPS? Okay, so there is something I need to check there. I don't want to go there on HTTPS, but there may be something redirecting automatically. Or is Grafana now? that's the risk I took by taking another version, because now maybe Grafana 8.2 is doing something on HTTPS by default. Okay, just let me actually let me do it slightly differently. Instead of taking this, let me take this. It may be better because I know we are doing a lot of stuff. Yeah, okay. I guess this is admin. New password. Well, admin is fine, no, isn't it? Well, just for the demo, I'm going to put admin again. This is not good, obviously, but okay. So that's it. I'm in Grafana. It's up and running. That's great. The first thing you will want to do, obviously, is to add Prometheus. So you add a data source, you go you go there, and we have HTTP, localhost, and Prometheus is on 1990 here. So, and that's it. If I recall correctly, I didn't set anything else. That's all I did. So that's it. I guess we could check here and then go here and see if we have like so I'm not used to this new UI. Dashboard, home, remove this panel. Okay, I thought that I did export one. Okay, here. So yeah, so we have Prometheus running. We have a dashboard about what's happening on Prometheus. That's great. Okay, so now, as I said, we want to go one step further and have some information about what's happening in NiFi. Bear with me. Now we are going to add the fun stuff. So the first thing we are going to add is the node exporter stuff. So if I go back to again to my console and we look at what's in Prometheus. Sorry, I did it twice here. Right now we see that we have some information like basic information, and we have a job name which is Prometheus and which is scraping itself. That's as it says, it's Prometheus scraping itself, its own metrics. So what we want to add as a beginning, as a first start, is the node exporter stuff. So the first step is going to be to change this. So not changes, but add some of the information. So the first step here, we have a job name Prometheus. That's great. Now we are going to add a job name node, and obviously this is not great in terms of indentation, so we need to be careful here. And here we want to add our NiFi nodes. And if you remember, the node exporter that is by default on all of the nodes is running is listening on this port. So in this case here, I'm going to add all of my nodes. So bear with me, just a bit of copy paste. So that's the first one. That's the second one. And that's the last one. Okay, so once we have that, we can save, go out, restart. I thought I had a restart, but system sigil restart Prometheus. I don't know, maybe it's not required to restart, but just in case, just restarting. Maybe it's just refreshing whatever is available in the new version of the file. I must say I'm not an expert on this. Okay, that's great. Now if I look at this, I already have the option to get a nice dashboard, and I'm going to show you, and that's something I can put on a GitHub location. So let me again switch back from the console to here and go into Prometheus here. So now I want to create a new dashboard, but I want to import it, and I'm going to upload a JSON file, and that's the dashboard I want here. And import, and hopefully this should give some useful information already. So by default, I think it should show the right nodes, but maybe not. I'm going to check if this is the right. Yes, these are the right nodes. So out of the box like this, I have some information here about disk usage. So that's already some useful information. I mean, it's not crazy, but at least this is some information. I have the disk usage for the OS. I have the flow file repository. I have the content repository. I have the provenance repository, and I have the disk usage for the logs. Now, obviously, we want to go one step further and have the heap usage for NiFi, active threads, flow files queued, back pressure prediction. But for this, we need to do the next step, which is really about scrapping the data exposed by NiFi. So let's do that, and this dashboard will be updated automatically. So let me go back to the console, and this is really the last step of what we will be doing today. Because otherwise it's going to be very annoying to go back and forth like that. So let me go back here, and let's do the last steps, okay? And that's it. I will show you the dashboard updated, show you another one that you can do, and that will be it for today. Obviously, as we discussed last time, or even earlier today, there is also a Prometheus reporting task, which is also something you could use in a very similar way to extract and expose very specific data from very specific parts of your flows in your dashboards. This is super useful. Okay, let me go here and go back. Here, okay, sorry. Okay, so one of the things we are going to need is actually to manage all of the stuff around the certificates, and I want to do it with you because, I mean, usually this is where managing the certificates and so on is really annoying. So I want to do it properly with you. So with Cloudera, we have some of the certs available here. We have our stuff here. We have our keys, we have the key store, we have the trust store that are used for the services running on this node. And in this case, these are we have the key store and trust store used by the NiFi registry, because the NiFi registry is running on this node. So that's something we are going to use. So basically, the first step is I want to copy the key, because I want to use the key to access NiFi. So basically, I'm going to use the key for this node as my identity to access the NiFi nodes and scrap the data for Prometheus. So let's go here. Let's change the ownership of the data, and then we want to change the data. So the first thing we want to do is to show the password, because this is going to be used. So we have the password now here. Obviously, all of this, for all of this, you need to be root. So you need to be a root user. So it's not like anyone can do it, right? So then you can change the type of the certificate, because Prometheus is going to expect the certificate in a very specific format. So in this case, you can change it, and we want the password here, and that's it. So we have now the key in the RSA format. And we also want to have this. And here again. So I don't remember exactly. So in this case, if I recall correctly, we want the public certificate and the private key exposed in RSA format. So here I'm changing ch mode and the owner of the file. That's it. That's all I need. I wanted a specific certificate and key to use to scrap the data on NiFi. But now, if I do that, now I can. So if I go into my configuration now, I can add an additional job, which is really scrapping the data from NiFi. So if I show you what it looks like, this is this. Okay, here. So that's the job we want. Obviously for targets, I'm going to remove it because I want to copy paste this one. And then I have the TLS configuration. So this is really what this is about. So we have the key, we have the certificate, and we have the certificate authority to trust what has been exposed, what is exposed by the NiFi nodes. Then we have the endpoint, which is exposed by NiFi, and we have the list of the nodes. That's really it. However, if we just do this, this is not enough. This is not enough. If I just close this and restart, I will get some errors because you need a specific. I mean, you need to set a specific permission for this. So let me switch back to my view here. Okay, so here it is. So now if I go back to Cloudera Manager, sorry, not Cloudera Manager, my environment in CDP, and I want to go in Ranger, I will need, oh sorry, it was already open. That's all right. I will need to add a specific role for the metrics. And I need to remember which endpoint this is, because if I recall correctly, this is actually the NiFi flow. There is no specific configuration for it. I'm just checking very quickly if there is a specific one or not, but yeah. So basically what we need is access to the /flow resource. Yeah, that's the one. So we need to add a policy. Actually, no, there is already a policy, but we need to add our node to it. So here, the flow right now is only available to the NiFi admins. We need to edit this policy to also add the NiFi identity. Actually, we only want the NiFi registry, but the NiFi group is containing all of the identities of all of the nodes, so we can do that, and that's just fine. And we can give read access, and that's it. So now this is enough. In the meantime, I'm restarted Prometheus, and this is restarted. And now if I go there, hopefully without doing anything, I should start seeing some data here, unless I did something really wrong. But hopefully this is all we need. I hope I didn't do something wrong in terms of configuration and such. So let me check just to make sure we are not waiting for something that is not going to work. But in theory, this is what we want. I'm checking if there are issues, but I think this is what we expect. So maybe I need to do some edits, because when I export things, so let me edit this just to make sure. I'm not waiting for something. So here, if I look at the metrics, so I have a lot of metrics from the node exporter, but I don't have the metrics around NiFi, at least not yet. So there is probably something not quite right yet. Yeah, okay, so it's not correct yet. So let me check the logs. I hope I'm not trying to do something that is like something new, and again, since I'm using a version that I was not using before, I'm just trying to make sure I'm not doing something stupid here. So I'm just okay, so I'm looking into the logs right now. I'm just trying to see if there is an error somewhere. Completed loading of the configuration file. It's not complaining about anything, so I guess it should be happy with it. Everything is as expected. So I do have my nodes here. Just checking if I did something wrong somewhere. But in theory, everything should be fine because it started, configuration is loaded. So I guess maybe I forgot something on my side. Okay, sorry, that's me. I think that's on me. I think. I'm not sure actually. No, it should be fine. Nope. No, I think this is as it should be. I will try to debug it and see if there is something I missed somewhere. I think maybe my copy paste of the configuration on the Prometheus side is not correct, or maybe they changed how to manage TLS config, but I don't think so. Matrix path, NiFi flow matrix. This is correct. What is weird is that all the logs are just fine. So let me actually try to add some graph here. No, I don't have the matrix there. Well, I don't know. That's a good question. I will need to look into this. That's weird. I don't remember doing something specific. Thanks, Maggie. Thanks for yeah. Good luck with your own NiFi Prometheus Grafana stack. Thanks for joining. Good to have you. Yeah, so I'm not sure what's happening here. Well, there is definitely something weird. I can check. Actually, something we can check thanks to Ranger is to see if Prometheus is trying to access my stuff here. So like, so it's trying to access flow. So we can resource name flow. And I know why it's not working. I'm sorry. This is me. I know why. This is, well, let me show you. I told you it was a bad copy paste. Sorry about that. I'm just being lazy and not paying attention. Let me go back here and just show you very quickly what was the issue. Let me resize correctly here. Yeah. Okay, so I was looking at the logs and it's looking good. It's saying that everything is fine, but actually I did something very stupid, that I copy pasted my targets, but I shouldn't, because in the first case we are accessing the nodes on the node exporter port. In this case we want to use the NiFi port on which NiFi is listening, because this is exposed on the NiFi web API. So here we want this. Oh, damn. Here. External keyboards is painful when SSHing to some locations. Okay, so here, and this is going to be much better. Sorry about that, just wanted to go faster, and in the end it was the opposite. So restart, okay, and status. If we look, everything is okay, configuration loaded, looking good. Okay, so now let me actually switch back to the other one. Where is it? That's the one. Okay, done. And actually now, if we look at that, and if I refresh here, hopefully we can see now that the cluster management node, so the node where Prometheus is installed, is accessing /flow. So now it's actually accessing the data, and if I go there, we have some data showing up here, and we can see that it's looking good. I mean, looking good. We do have some data, and it's showing what we expect. So basically here we have the heap usage. Here we have the active threads, flow file queued per node, and MAC back pressure. So we have back pressure on one of our connection, which is correct. Here we have back pressure, so that's what we were expecting, and so we have this data available. Now I'm not going into more details, but because now you can look at how many metrics you have. Like so if we go there, edit here, you can select very specific process groups for which you want the metrics. So by default, in this case, I'm using the root process group because I want very high level metrics for all of my NiFi deployments. But you could go into very specific process groups for very specific use cases and have dashboards dedicated to specific use cases. And you can go very far with it. Very quickly, because then you can just go through all of the metrics exposed very quickly, and I will that will be the end of my live because it's already quite a long one, especially after my day. You can also have in the reporting task very useful stuff. So if I stop my QueryNiFi reporting task here, sorry, stop it, and configuration. So we discussed about this information here. In the sync, you have a Prometheus record sync. So everything you can query using the QueryNiFi reporting task is something you can also expose into a specific sync. So you could say something like, I don't know, if we go to the documentation, and you could say, okay, I want to get all of the information about a processor for all processors where the name of the processor is ending with Prometheus. So you could say your developers, your flow designers, well, if you want all of your metrics to go into Prometheus and Grafana, please make sure that your processor is ending with the given suffix that you agree on. And once you have that, without doing anything, all of the metrics will be exported to Prometheus, and the team in charge of building the use case will be able to add these specific metrics into their dashboards. And something that is super useful, for example, is the number of invocations and the processing time for each of the invocation in nanoseconds. These two metrics are super useful. This is something super useful, and you can do it this way. And also, you can also have the Prometheus reporting task here, but to be honest, there is no real interest to use this one. It wouldn't provide much more information than what you have out of the box. If you use the Prometheus sync, here is the configuration, what it looks like. So here is the configuration for the NiFi job to access the API exposed by NiFi for Prometheus. But then if you want to use NiFi sync, this is very similar basically. You provide a path, this is your own, and you provide a port, this is the one you want to define. So if I go here and I show you the configuration here of the Prometheus sync, sorry, I'm going to Prometheus sync, you just select the port you want to use, and this will be on the /metrics endpoint. That's all you need to set up. If you want to do this in a very nice way, obviously you want to define a reporting task here with no authentication, but at least the scrapping of the monitoring data is encrypted over the network, and you could have authentication to force MTLS if you want mutual authentication between the two, and that's it. So that's where I set 1998, and then in my configuration I was using this. So you give the targets. Don't forget to change the ports. Don't make the same mistake as I did. The path is metrics, and then you provide the certs, and that's it. In this case, you don't need to set ranger policies. And as I was showing last time, in terms of dashboards, this is the kind of stuff you can have. Like this was the dashboard I created for data ingestion. So really a use case where I receive flow file from a listen HTTP processor and then send it into a publish Kafka record processor. So I had some information about the amount of data received and sent, the average lineage duration. So how long does it take for me to receive the data from my HTTP listener and send it successfully into Kafka. And in this case, we can see that it was taking less than 1 second in average. So this is something we want to check. Same as flow file skewed is something very important. You always want to be alerted in case back pressure is going to kick in. That's really important. And then I had another use case where I was consuming data from Kafka, doing some enrichment using HBase to do a lookup records into HBase to enrich my data and then send it into a Solar cluster so that I was able to build some dashboards on top of it. So my use case was really listen HTTP to Kafka. This was the data ingestion part, and I had a dashboard for this, and then consume from Kafka, enrich with HBase, send into Solar, and that was my monitoring dashboard for what was happening in NiFi. And what I was talking about that is provided with the Prometheus sync is to get some very specific details for very specific processors, especially in this case the number of invocations and the average processing time per invocation. And we could see here, and this was a very interesting metric here, that the average time for lookup into HBase was about 38 milliseconds, which is great. And something that was really interesting was to see it on a longer period of time, because at the very beginning we were able to see that this average processing time, invocation time, was decreasing, because obviously HBase is going to let's say to make sure the data is correctly distributed across the region servers and so on. So it was really nice to see the lookup time decrease over time because of how HBase is working. So that was really cool. So this is the kind of dashboard you can build with everything I've been showing today. 3 hours of live. It's been a long one. It's completely dark outside now. I'm going to stop here. Thank you. I'm not even sure there is anyone left in the chat. Yes, you are still a few. There is still a few of you. So thank you for following this live stream. I hope it was a bit useful, a bit interesting. The next one will be next Thursday. Last time I said that it would be on Wednesday, but my Cloudera job is taking more importance on next Wednesday, so it will be next Thursday. It may be a bit earlier because doing it at this time for me is a bit late my time, so it may be 1 hour earlier in the day. I will see. I'm not sure yet. I will let you know. I will update my schedule on my Twitch channel. But yeah, see you next week. I'm not sure yet what I will be talking about. That's a good question. I'm thinking that maybe I will be talking about NiFi registry and CI/CD and the topic that I discussed in a webinar, but it was kind of the same. Like I did a webinar, I was going through all of this stuff, but I was not really taking the time of going step by step of what is happening in the backend. So talking about NiFi registry, CI/CD, automating flow deployments, maybe what I will be talking about next week. I'm not sure yet. Something I'm also considering is actually doing live streaming while reviewing pull requests that are opened upstream. There is actually a pull request where some people are asking me to review it and merge it, which is about supporting AWS IAM for the Kafka processors. So maybe I will be showing how anyone can really do a review of a pull request, because to be honest, we have a very active community, but if we had more people helping with the reviews, we would have even better stuff available in NiFi. There is a lot of pull requests with awesome stuff, but we just don't have all of the time we would like to have to review and merge all of this. So yeah, so I'm thinking about doing a live session to show you how I review a pull request, how I build some NiFi code with a pull request, and test it and make some comments. This is something I'm thinking about. So maybe this will be something I will be doing next week. I don't know. Feel free to reach out to me on Twitter or LinkedIn if you want to discuss specific topics. Always happy to hear about it. It could also be just go end-to-end use case flow design. That could be also an option. I could also be talking about NiFi stateless, and there is also a lot of things I would love to talk about around edge management and the NiFi agents. The NiFi agents are really, really powerful, and I don't think this is used enough as of today. There is a lot of things that can be done with the NiFi agents, and I would love to make a session on this. So I think this will also be super useful. Anyway, drop any suggestions, send me a DM on Twitter, whatever is easiest for you, and happy to work on something that can be useful and interesting. So anyway, thanks again for joining this live session. That was useful, I hope, and see you next week. Thanks again. Bye. Enjoy the rest of your day.